Hi, so I've been wanting to do this for a little while, and we've got a really nice day for this experiment actually. It's kind of a bit of sun, a little bit of wind, and where I'm from we call it a drying day. So I'm going to give this experiment a go. Now, what it is this idea that if you try to heat a bulk of water directly from the sun, of course you've got a massive bulk, you've got to raise the temperature of that, it takes ages, and then you start to get evaporation, and sometimes that can take all day. So by the time it's evaporating, you've gone into the night and everything's cooling down. And then there's the idea that if you can separate those layers so that instead of trying to heat the bulk of water, all you're trying to heat is a tiny fraction of that water that you're separating from the bulk, it should be much more efficient. Now, a couple of universities have done work on this using graphene foams, and of course graphene foams aren't that easy to actually get hold of or make. So I was pondering this problem really, and this is my solution to it. I don't know if you've ever met this stuff. It's Oasis foam. They make this as I think it's a polyamide. I'm not quite sure actually, I'd have to check. This is a petrochemical version. You can get organic versions, I think it's the brown foam, but this is the petrochemist version, the stuff that you can buy in just about every florist. And this is amazing stuff. It's supposed to mimic the plant cell. And if I pop that into water, it will wick the water up like that far. It really sucks the water into it and keeps that water, which is an awesome thing when you think about it. Now, of course, if we do that and direct the sun on here, it's maybe going to get warm. But I have this as well, which is a black carbon felt. This is an activated carbon felt, actually. And my thought is, if we get that bulk of water and we stick in the Oasis, and then we lay some felt on top of it, the sun will heat the black, because it's black. The Oasis will wick the water into the carbon, and we should get a more efficient and faster rate of evaporation. Well, at least that's the idea. Now, in order to test that idea, what I've got is two Pyrex dishes. And I plan on putting the same amount of water in each one, and then in one of them laying out the Oasis and the felt as I've just described. And then we can check them. We just give it an hour, and every hour weigh the two. The only loss in there is going to be evaporation. Obviously either evaporation by the sun or evaporation by the wind, but it's going to be the only loss in there. So as we weigh them, we should start to see a difference in the weight, fingers crossed, of the one with the felt and foam. The felt and foam obviously weigh next to nothing, and I'll normalise it, so I'll fill them up and weigh them, and then we can calculate what that water weight is and put the same weight of water in. So that's the plan. Let's give that a go. Okay, I dropped the foam in and you can see the water wicking up there almost immediately, which is really cool actually. So I just wanted to show you how quickly that wicks. Okay, so nice and simple setup. Here's our Oasis with our black carbon felt on it. Here's our bowl with nothing in. This is 2 kilos of water, so 2 litres, exactly the same here, 2 litres of water. Let's set them outside in the sun. Set a timer going, and then every hour go and take a weight measurement. Okay, so this is the setup, and it's pretty simple stuff. All I've really done is put these 2 bowls of water out on a wall in the sun and the wind. And this one is actually responding about 50% better than this one. So this is evaporating a hell of a lot quicker than this is evaporating. Now, it's been a relatively cloudy day, so the sun has been in and out, and I've been measuring it every hour to see what the weight difference is. And I've noticed that when it's gone through cloudy periods, this one slows down. When the sun is directly on it, it actually gets really, really quick. And that's no surprise when you think about it, because we've got a black surface on there, and that's absorbing all that solar radiation, and the black is heating up, and that's what's heating up the water and improving the evaporation. This one actually doesn't go noticeably quicker or slower depending on the sun or the cloud. I imagine if I'd left this directly in the sun, it was a hot day, we would notice a difference between cloudy and sunny on this one as well. But this one, the difference is much more marked. So the wind helps it to evaporate from the greater surface area that we've got in this. But when the sun hits that black, that rate of evaporation actually gets quite dramatic. Anyway, it's been running for about 6 hours. Let's give it some more time. Okay, so I ran it for 9 hours and I brought it in because it's getting cool and it's getting dark, and to be honest, the results are awesome. I mean, you have to think, what is exciting about sticking a couple of bowls of water in the sun? So we did one, which is our test, where we just put the bowl of water in the sun. And it was quite patchy. I mean, it did okay, actually. It lost 262 millilitres. So 262 millilitres in 9 hours has evaporated out in the conditions we've got at the moment. However, this one lost 399 millilitres. In fact, it's 152% better than this one. So we had quite a dramatic improvement, actually, just by putting this Oasis with this bit of felt in it. And that's all it is. It's a little bit of carbon felt on a couple of blocks of Oasis. And it has an astonishing and dramatic effect. Now, there was about an hour when the sun was really out. It was quite a cloudy day, so the clouds were going over, the sun was coming in and out. But for about an hour in there, we had a constant sunshine. And this one lost 63.5 millilitres in that time. And in the same time period, this one lost 37 millilitres. So that was about 100, well, that was 153%. So we got a great deal of evaporation when the sunlight was directly on this black. And as I said earlier, that's no surprise. The black is basically absorbing the infrared and getting hot. So what's happening, or at least what I think is happening, is this Oasis is wicking the body of water, wicking the water up from the main body into a large surface area. That then is being wicked into this felt, which is an even larger surface area, and the felt is busy absorbing the heat of the sun. And so it's evaporating like crazy. And that is actually stunningly awesome, because there's so much about this little system that I like. One, it's super simple. I mean, how simple can you get? Two, it's really, really cheap. And that's fantastic. So this is something that could be replicated, obviously in large scale. I mean, we've got a bit of A4 here. So it's something we could replicate in large scale that could be done relatively cheaply with basically next to no skills. Now, this Oasis will float. So if we put that onto a massive deep pool of water, the Oasis will float on the top, keeping the carbon foam from sinking into the mass of water. So this carbon felt, rather, will always be a large surface area. It's not going to get swamped and soaked. So what are the uses of this? Well, in 9 hours, we were able to produce 399 millilitres of water. That's a really good drink from a bit of A4. So if this water here were just muddy water or salty water, then that surface area could produce 400 millilitres in an English afternoon, which is pretty cool. Put that anywhere else, that should be able to produce a hell of a lot more. So if we angled a piece of plastic sheet over there, let it evaporate and condense, it would run down, and we have a more efficient solar still. So this makes a solar still for the purification or desalination of water. Now, it doesn't use reverse osmosis, obviously. As it concentrates this down to a brine, then these will clog, I imagine, but then washing them out is just a way of revitalising them. Now, the top bits would probably be dead easy to give a swish around in some brine and give that a clean, so it would be cheap to maintain as well. So I think it's a very exciting result, because we're able to distill a huge amount of material using extremely cheap methodology. That, I think, is really exciting. So although really what we've done is put a couple of balls out in the sun and watch them evaporate out, the result we've got for this little setup with the wick and the carbon, I think, is astonishingly impressive, and certainly a way forward for the purification of both dirty drinking water and salt water. So I thought I would share that with you. I'm going to continue with this. I'm hoping it's a bright sunny day tomorrow and not so cloudy, and we can see what some real sun will do with it. But I'm going to continue with it a bit. But I thought I'd share that result with you, because I personally found it extremely exciting, and it's such a cheap and easy thing to replicate. You're worried about this stuff being non-biodegradable, then give it a go with the biodegradable stuff. It has the same properties, so give it a go with the stuff that will be harmless, in inverted commas. This stuff, you can get this carbon felt online. It's used for air filters. Anyway, I hope you enjoyed the video, and thank you very much for watching.